Hello everyone, I am Mahananda. I hail from a beautiful place called Kamareddy which is located in Telangana. I am currently pursuing third year Bachelor's of Technology in the stream of Electronics and Communication Engineering at RGKT Basar. Now I am going to present a project which is microcontroller based washing machine simulation. First of all, I would like to thank Emergis Technology for providing this wonderful opportunity, and it is an online virtual internship which is related to embedded systems. So, starting with the contents, first overview, goals of the internship. In this, I would like to explain what I have learned during this online virtual internship, and later a brief explanation about the embedded systems and a brief explanation about tools which are required for this project and implementation details, conclusion, and later I would like to end up this presentation by giving a small demo of how actually the project will works. Now, coming to the overview and goal of the internship, this project mainly focuses on simulating a washing machine using the Pixim Lab. Pixim Lab is an online board simulator by which we will be simulating a washing machine, and the aim of this project is to replicate a real world washing machine functionality in virtual environment. First of all, we will go with the understanding what is embedded systems. Embedded systems is nothing but it is a combination of hardware and software which is intended to do a specific task. For example, washing machine, microwave oven and refrigerator. Coming to the project requirements, this is the basic block diagram of the project requirement. The machine will power on by pressing the switch 5 and it will pauses or stops by pressing the switch 6, and we will be navigate between the options by continuously pressing on the switch 4, and the switch 1 will indicate the door status of the machine. These all are the input peripherals of the microcontroller, and coming to the output peripherals, CLCD, buzzer, motor are the output peripherals of the project requirements, and the software which I have used in this project is MPLAB X IDE, and the compiler is XC8 compiler. Board which I have used in this project is Pixenius board on Pixim Lab. Now let us understand what is microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. Here I have used the PIC16F877A microcontroller. The reason behind why I use the PIC16F877A is it is very convenient to use, and programming of this is quite easy, and it has 40 pins. Out of 40 pins, 33 pins are allocated for the IO operations, and it is also featured the EEPROM. EEPROM stands for electrically erasable programmable ROM, which makes it possible to store some of the information permanently. And the reason behind using it is the cost of this microcontroller is also low and it is easy to handle. It consists of two 8-bit and one 16-bit timers. Now let us discuss about the peripherals which are attached to the microcontroller. Starting with the LED. LED stands for light emitting diode. Unlike a normal diode, in normal diode energy will be dissipated in the form of heat, but in case of LED the energy will be dissipated in the form of light. It will work as a diode so that it will be used in most of the embedded systems application. The reason behind using it is it will consume the low energy and it has a longer life, smaller size, and it is faster. And the next peripheral is CLCD. CLCD stands for character liquid crystal display. It is an output component which is used to displaying the character. In Piximlab we have two options. One is 16x2 and another one is 16x4 displays. 16x2 is nothing but 16 characters in 2 lines. 16x4 is nothing but 16 characters in 4 lines. The next peripheral is digital keypad. Digital keypad is mainly made up of the tactile switches. As shown in the figure, it has 4 rows and 4 columns. Tactile switches are turned on when the keys are pressed, and it will be turned off when key is released. In Piximlab Pixenius board, digital keypad keys are interfaced in a pull-up resistor manner. One of the major problem with this digital keypad is bouncing effect. Bouncing effect is nothing but spurious pulse detection while pressing or releasing the tactile switches. Coming to the next components, ISR, fan and buzzer. ISR stands for the interrupt service routine. It will tells to the processor or controller to what to do when the interrupts are occurred. Interrupts can be because of the hardware or software changes in the program. In our project, we require a timer to create an interrupt once the washing process is over. For this, I have used timer 2 of PIC16F877A microcontroller. Then I have also used a fan for this project. Fan is used for the washing process like rinse, spin and dry. Onboard and passive cooling fans are now mostly used in all desktop computing and embedded systems. And the next one is buzzer. It is used to indicate when the door of the washing machine is opened, and when the program is completed it will make a short buzzing noise. And in this PPT this is the image of the fan and this is the image of buzzer. Now coming to the implementation details, as soon as board is reset means once the hex file is loaded into the PiximLab, it will show on LCD like press key 5 to powering on the washing machine, and once the switch 5 is pressed it will show on the CLCD like powering on the washing machine. Next is the washing program screen. The washing program menu will contain the following washing options: daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. Like there are total 12 options are there on the washing program menu. By using the switch 4 on keypad we can scroll between the options available, and we will be select an highlighted option with the star by long pressing the switch 4. And the next is water screen. This screen should allow the user to select the water level. The water level menu will contain the following displays like auto, low, medium, high and max. Using the switch 4 on keypad we can scroll between the options. It is similar to the washing program screen menu, and we will be selected the highlighted options with star by long pressing the switch 4. Next is start and stop. Once the washing program and water level is selected, the user will be provided an option called start the machine. If switch 5 is pressed, start the machine, display the function selected and time taken. And if the switch 6 is pressed, go back to the washing program screen and again select the highlighted option with star by long pressing the switch 4. The next is once the machine is started, display the function ongoing. It can be wash, rinse or spin, along with display the time left on the CLCD. If switch 5 is pressed, start the washing machine. If switch 6 is pressed, pause the washing machine. The status of switch 1 is it is the indicator of door status. If switch 1 is pressed, turn on the buzzer and display door is open, please close. Once all the programs are completed, display the notification as program is completed, remove the cloths on CLCD. Coming to the conclusion, the simulation of the washing machine using PiximLab was completed. In this I have learned the embedded C which is required for the programming of the microcontroller, and it's also offered a hands-on experience that converted the theoretical knowledge into practical. This virtual internship was provided a strong foundation for exploring in the field of embedded systems. Next, I would like to show the project demonstration. This is the project code. And first of all, I will clean and build the project. Here it is built successful, and then I will upload the hex file into the PiximLab. Here is the PiximLab. Here I will select microcontroller as PIC16F877A and board is PIC board. Now I will upload the hex file. In the MRG, it is washing X file. I will open this folder and dist default production. Now I had selected the hex file and uploaded it. As soon as board is reset, it will showing like press key 5 to power on the washing machine. Now I will press the key 5. It is showing like powering on the washing machine, and then it will go to the washing program menu. Here there are 12 options are there. By pressing the switch 4, we will be navigating between the options. Here there are the 12 options, and by continuously pressing the switch 4, we will be selecting option. Here I had selected the eco cottons option, and next it will come to the water level, and there are some certain options are there, and by pressing the switch 4, we will be navigate between the options. Those are low, medium, high and max, and by continuously pressing the switch 4, we will be selecting highlighted option. Here I will select the medium option. Now it is selected, and again the next screen is switch 5 to start and switch 6 to stop. I will press the switch 5, then machine will start working. Here you can see fan is running, machine is started, and again there are two instructions. 5 is to start and 6 is pause. When we press the 5, the machine will start, and when we press the 6, the machine will stop. Switch 1 is the indicator of door status. When we continuously press the switch 1, it will show us like here it is taking time. When I will continuously press the switch 1, it will shows like door is open, please close. And again it will shows like 5 is to start and 6 is to stop. If I press the switch 5, the machine will start working. And after completion of time, it will show us like program is completed, please remove the class, and again it will go back to the washing program, and again we will like to select the highlighted options. This is the project demo. And I would like to thank the Emerging Technology for providing this wonderful opportunity. This internship is not only provided the hands-on experience, it is also helps us to explore the more about the embedded systems. Throughout this virtual internship, I have learned embedded C programming and embedded systems and its application, microcontrollers, core concepts of functioning of components and on microcontroller boards, and communicating protocols, timers, interrupts, and PixSimLab simulation tool, MPLab XIDE, embedded C editor and compiler, PIC16F877E microcontroller and their working, digital keypad, push buttons, LEDs, fan control, buzzer. This virtual internship pushed my skills to the next level.